Okay, so another thing that we can talk about is now that we've talked about how EWGs can affect the stability of the molecule, we can really use this theory or this idea to talk about how strong an acid is. And so what we're going to find is that if we have an acid, it's going to be if it's a strong acid or a strong HA, that means that's saying that the molecule is really willing to lose a hydrogen, then you can say that the conjugate base is going to be very stable as that conjugate base. So we're going to use the word stable kind of synonymously with a weak base, because when we talk about something being a base, we're saying just how easily that molecule can attack and rip off a hydrogen from something else. So if something's going to be a very strong acid, it's going to be a very weak base, and if it's a weak base, it's going to be willing to hang around for a while, so it's going to be stable. Okay, so if we wanted to compare and contrast then these two molecules up here as they're in their acid forms, let's say we have this molecule right here, okay, and then we'll compare and contrast to this EWG attached to the molecule. So this EWG, and so then we can say that if we lost a hydrogen from both of these guys, we would have the conjugate bases form. And so then if we use this principle right here, that really strong acids are going to yield very stable conjugate bases, we can use this idea from above that if you have an electron withdrawing group, you're going to stabilize the molecule. So then you could then say, since you have this very delocalized electron cloud for this molecule versus this very dense electron cloud for this molecule, of the two, this is going to be the more stable molecule. So this is going to be more stable. So if this is the more stable molecule, it's also going to be the weaker base. And if this is also the weaker base, then this molecule right here is going to be the stronger acid.